So today we want to talk about scientific notation. Hopefully you've done some scientific notation in your algebra class already and you're familiar with it. If not, hopefully this explanation plus the one in your book will help you to understand what scientific notation is all about. The reason we use scientific notation is because sometimes we have really large numbers or really small numbers, and to write them in scientific notation just makes them a little less cumbersome because we're not writing quite so many zeros. So we'll start out with a couple of numbers that are written, it's called in decimal notation, just regular decimal numbers. And we're going to put these into scientific notation. Now when you put something into scientific notation, you only want to have one digit to the left of the decimal point. So here, in place of having the decimal point at the end, I'm going to put the decimal point in between the 4 and the 3 so that I just have one digit to the left of the decimal. So that's going to be 4.3657. And then the question I have to ask myself is, how many times do I have to multiply that by 10 in order to get this number? The easiest way to do that is to count how many places I've moved the decimal point. So if it was here, I've moved it 1, 2, 3, 4, 5, 6, 7 places so that I could get it to right here. So that means there's going to be a 7 on my 10. How about if I start with a really small number? Well, in this case, again, I want the decimal point to go right here between the 4 and the 7. So this will be 4.75. And what number am I going to have up here as an exponent? Well, the decimal point has to go 1, 2, 3, 4, 5 places. But because it's a small number, this means that I'm going to have to multiply 10 to the negative 5, which just means I'm multiplying by a very small fraction, because this would be in the denominator. Okay? So the easiest way to remember it is that if you have a positive number on the 10, that started because you had a large number to start out with. If you have a negative number on the 10, it's because you had a really small decimal to start out with. So now let's take a couple of numbers that were in scientific notation and let's put them back into decimal notation. 2.749 times 10 to the third, that 3 means that I have to move the decimal point 3 places, and it's positive, so that means the number needs to get bigger. So if I move it 3 places, 1, 2, 3, this number would be 2,749. Okay? 1.4 times 10 to the minus 5th, if it's a negative number, that means I started out with a really small number. So that means I've got to move this decimal point to the left 5 places. So here's 1 place, and then I have to move it 4 more. So I'm going to fill in those places with decimals. So it's going to be 4 zeros, and then a 1 and a 4. So if I count, 1, 2, 3, 4, 5 places is how many places I've actually moved it. Okay, so again, if the 10 has a negative number on it, it means you started with a really small number. If the 10 has a positive number on it, it means you started with a much larger number. I want to do one other problem for you today. We did a problem a couple of videos ago where we changed meters to inches and we had to use 2 conversion factors. I want to do one for you where we're doing 2 conversions all in the metric system. Let's say that I have 0.049 kiloliters and I want to change that into milliliters. If you have a situation like this, you always want to be sure that you're changing it to the base unit first. So the base unit is going to be whatever the unit is without a prefix. So in this case, your base unit is going to be liters. I don't have a conversion factor to go straight from kiloliters to milliliters, but I can get it to liters. So I'm going to take what they give me, 0.049 kiloliters. You put that over 1. That's the way we always start. The next conversion factor I use is going to have kiloliters on the bottom. And the relationship that I know is that kiloliters is related to liters. And if you have your conversions memorized, like I told you that you needed to, you know that 1 kiloliter is the same as 1,000 liters. And then your kiloliters is going to cancel out. So that's going to give me liters Now I need to get to milliliters. Well, I know how to get from liters to milliliters because I know a conversion factor for that one as well. So my next one is going to be liters, and I'm trying to get to milliliters. So notice that I always put the units that I want there first, and then I put the appropriate numbers with them. Hopefully, again, you remember that 1 liter is the same as 1,000 milliliters, and so liters cancels out, and then my final answer is going to be in milliliters because everything is canceled out. I'm going to take 0.049 times 1,000 times 1,000, and that's going to give me a final answer of 49,000 milliliters. I had 2 significant digits here. I've got 2 significant digits in my answer, so I've got the right number of significant digits. I have my units, and I'm going to box my answer.